So circumference of a circle. Circumference is really just a fancy way of saying the perimeter of a circle. It's the distance around a circle. Okay? The distance around a circle. Perimeter of a circle. Okay? And then the formulas that you could use, don't write both of them down, okay, if you really don't want to. Write one that makes sense to you. The circumference could be 2 pi r or just pi d. They're the same things, okay? The reason they're the same thing is because the diameter is really the same thing as
2 pi r.
2 times the radius, okay? 2r is the same thing as d. So if you take pi times 2r, you just get the same thing as taking pi times d. So whichever one you use, great, okay?
No, I was going to go to the top.
Don't think that they're two different things. They are the same thing, okay? Personal preference, I use this one because this one is close to the area formula, and initially I think I had problems screwing them up, okay? Pi r squared was too close to this one, so I just, for circumference, I remembered pi d, all right? So that way that one had a d in it and the area one did not. Really the best way to keep them straight is the area formula has a squared in it, which makes sense because area is units squared. So as long as you know that the area one is pi r squared versus 2 pi r, you'll be in good shape. Okay? So that's your formula for circumference of a circle. We talked about that when we did the area of it anyway. And you'll have just a few problems involving circumference. Alright? I'm not going to spend a lot of time on it. Yeah, maybe we'll do just a couple actually. Everybody got that written down?
Yeah. Sorry.
Here's my first example. What is the circumference of that circle? Okay. Let's do both exact and approximate. Okay. Let's do exact and approximate, just like we do area. What is the circumference of that circle?
Pi d. So 12.
Calculators are over there. Yep.
12 pi. 37.67. 37.7. 37.6.
Okay. I'm kind of hearing it. Which one do you use, Colton? The 2 pi r or the pi d?
Pi d.
Pi d. Okay. So in that case, what did you use for your diameter?
12.
12. 6 is your radius, so 12 is your diameter. He's using this one, pi times d. The diameter would be 12, so pi times 12, or we just say 12 pi. Let me put a label on it, inches. And so the circumference would equal 12 pi inches. Not inches squared, because we're not working with what?
Area.
Area. Circumference is not an area. Circumference is a length. It's how far it is around if you had to walk around it. So circumference equals 12 pi inches, or if you rounded it, okay, Carson, I think you had it, what'd you have?
37.70.
37.70?
Yep.
Everybody agree with that rounding?
Yeah.
Alright.
Yeah.
Okay, so 37.70 inches. Any questions on that? Okay. The other type of problem, I might say the circumference is 28 feet. Find the radius. And let's go nearest hundredth. So I'm giving you circumference. You got to work backwards and figure out the radius. Okay? So what do you think I'll probably set up?
28 equals pi d.
Okay, so if you're using pi d, 28 equals pi d. What would you do? Divide both sides by pi. So d equals whatever that long decimal is. But I said to find the radius. So after you get this answer right here, what would you do? Divide by 2, because you want to find the radius, and the radius is exactly half the diameter. And to the nearest hundredth will help.
4.46.
4.46. Ethan, you agree?
Yeah.
4.46. Okay.
4.46.
So the radius is about 4.46. What I say? Did I give? Yep, I did. Feet.
That is a big number.
Okay.
I'm doing this right. 8.91768.
What's that?
I'm not using pi d. I'm just using
2 pi r.
Yeah.
Yep. It's exactly the same. Whatever you're more
You
comfortable
just
with.
divide by 2 and then divide by pi.
Divide by 2, then divide by pi. Perfect. Yep. Yep.
You're good.
Or vice versa. Divide by pi, then divide by 2. That would work too. Okay? Any questions on that? Okay, there'll be just a few problems with circumference. Next. Area of regular polygon.
But it also did say that right there.
Okay?
87.
Alright, first of all, vocabulary review. Who can tell me what a regular polygon is?
A polygon that has equal angles and sides.
Okay? So, you could have, that could be a regular polygon, assuming all the sides and all the angles are the same. A square is a regular polygon. Okay? I'll do my best. I'm getting a little bit long. That's meant to be a regular pentagon. Okay? All sides and all angles are the same.
That one's
Right.
good.
Regular hexagon. Okay?
Your left side's off.
Thank you.
Got you.
So regular means all angles and all sides are equal, right? Okay, that's the biggest thing I want everybody to know. So if we're going to find the area of these, okay, obviously you have ways. Triangle. Okay, if you know the base and you know the height, you can find the area. Okay, square, if you know the length of this side, you can find the area. You have other ways to find the area, okay, but sometimes you won't be given that information, okay, and then you especially don't have ways to find the area of the more complex polygons yet, okay. So sometimes what you will do, and I'll even draw an octagon here. Sometimes, and with the more complex ones, what you'll do is you will notice that every regular polygon can be cut into congruent triangles. Every regular polygon can be split up into congruent triangles. And then, if you just find the area of one triangle, you have essentially found the area of each of those triangles. So in this case, if you find the area of one triangle, you could take that answer and multiply it by however many sides there are, however many triangles there are. In this case, there are 8 of them. So if I wanted to find the area of this octagon, I would just find the area of one triangle and multiply by 8. Okay? If it were a pentagon, find the area of one triangle and multiply by 5, because there's 5 of them. Okay? Are you guys following this logic?
Yeah.
Okay? Find the area of one triangle inside it and multiply it by how many sides there are or how many triangles are created. Okay? And the way you create congruent triangles is you go from the center out to a vertex, out to a corner. Okay? That's how you create the triangle. Okay. So, in order to find the area of a regular polygon, what I'm going to tell you to do is find the area of one triangle and multiply that by the number of triangles. Or we'll maybe just say number of sides. Number of sides or triangles. I got a vocabulary word, and then we'll go ahead and do an example. Okay? I had never used this vocabulary word until I started teaching geometry after college. I never had seen this word when I was in high school. Okay? Basically, because the way I found the area of these things was I just split it up into triangles, just like I'm talking about. Okay? Maybe this vocab word did exist and I just ignored it. Could have been the type of student I was. Okay? As long as I can get the right answer, I didn't really care. All right? But an apothem, all this is the height of one of the triangles in a regular polygon. Okay? So when you see the word apothem in the assignment, it's just referring to the height of one of the triangles in that regular polygon. That's all it's referring to. Okay? But that's going to be helpful, right? Because if we're going to find the area of one of the triangles, how do you find the area of a triangle? Base times height. You got to have the height, right? So that's what this is helping you with. But I don't know. I just never called it that. I just called it the height of a triangle. Okay? So anyway, when you see that, that's what it's referring to. Okay? Got that? Yeah. Okay. Alright, so we'll do one here. Let's say we got a hexagon, regular hexagon. The apothem equals 8 inches, and each side equals 6 inches. Find the area. Okay? Yes. Yep. Now, the problems you get, I'm going to draw the picture out for you. But even in a problem like this, if you feel like you can't draw a hexagon, fine. Just draw a triangle. And once you get that answer, multiply it by 6. Once you draw the triangle, find the area of the triangle, and then multiply it by 6. Even if you can't draw a hexagon, which you're not being tested over your drawing abilities, okay? All right. If you can't draw a hexagon, fine. Draw a triangle, find the area of it, okay, and multiply it by 6. Now, I'll draw one for you, okay, hexagon. So 1, 2, 3, that's wrong, 4, 5, 6.
Now then, I'm just going to
Okay. So here's one triangle, right? I'm going to take that triangle and move it out here and draw it, okay? We know that one side of the hexagon, or every side of the hexagon, was 6 inches, right?
Yeah.
So this right here was 6 inches, the bottom of it. Everybody see that? The apothem is 8 inches. Well, remember, the apothem is really just the height of one of those triangles. So really, I know that this right here is 8. Yes? No?
Yep.
Okay. Could you find the area of that triangle now?
Yeah.
Yeah.
Base times height
Divided
divided by 2. Base times height, 48, divided by 2, 24, right? So area equals 6 times 8 divided by 2, so 48 divided by 2, that gives me 24. But that's just the area of what?
One triangle.
One triangle.
So
How many triangles
6.
will there end up being? 6 of them. So I'm going to take 24 times 6.
144.
144 inches squared. 144 inches squared. Okay?
Yep.
144 inches squared. The book's going to give you a formula for this, okay? If you want to use that formula, you're welcome to. Okay? The reason I don't give it to you is because you'll forget it. This is easier, makes more sense, no new formulas memorized. You should know the area formula for a triangle. Find the area of one triangle, multiply by how many there are. Okay? It's actually going to be somebody calling. Nope. All right. About 5 minutes.
Yeah, it's 9.
Where you at?
Which one was it?
Cloudy days.
So, there are a couple circumference problems out of the textbook. And then because I thought the textbook didn't have very good polygon ones, we created a worksheet of a grand total of 6 of them.
No, we're doing this first. What? The worksheet? Yes.
I have one more thing to give you. It's not work, it's something to keep track of stuff, if you'd like.
Oh, yes.
This packet, guys,
Anthony.